Hello, everyone. Good afternoon, wherever you are. Thank you for joining me in today's session. This will be our data engineering / MLOPS coding session. This will be the first for this cohort. Thank you for joining. We apologize for starting a little bit behind schedule, just from technical issues. Okay, we'll just dive right into it. Today, taking us on today's session, we have Hakim Edward, who is a junior data engineer at Hammer AI Labs, taking us on today's session. Hakim, the floor is yours.
Yeah, good day. Can you hear me? Good day, everyone.
Yeah,
Can you
we
hear
can
me?
hear you. We can hear you
It's
clearly.
nice to be here again once again. Today I'll be talking about deploying TensorFlow models with TF7. Am I audible enough?
Yes, you are. Yes, you are.
Okay, so it's nice to be here again. So is my screen visible? Is my
Yes,
screen
it is.
visible? Yeah, all right. So today I'm going to talk about deploying TensorFlow models with TF7. Yeah, let me just get right into it. So today, I've, we have trained. I'm going to show you how to train it, a TensorFlow model, and we're going to make a prediction, deploy it, and make a prediction. It's using the URL that we get from it. Right? So for now, I will start by discussing the model I'm going to deploy. Yeah. So it's all on GitHub. The link to the repo is all on GitHub, so it's visible to everyone. So what I'm going to do today is MNIST data set classification. The the popular data set MNIST of images of numbers from 0 to 9. Yeah, and we're going to build a model that's going to classify the numbers according to the pictures that it gets. Yeah, so I'm not going to explain the code. Am I audible enough? Hello.
Yeah, go on. We
Hello,
can hear you.
okay. So for this code, we're just going to train an MNIST data set. So we're just going to load the data. We're going to load the data from TensorFlow carriers. I'm also going to reshape it. Yeah, this is reshaping to a single channel. You know, normal images come in height by width by channel. So I'm going to make it just one channel that is black and white. I'm going to normalize it here. This is normalized. This is the normalizing code. We're going to divide by the maximum pixel. That's 2255. So I'm going to set the image shape to the first index, and I'm going to set number of classes to the number of what do you call it? Number of classes in the chamber. That is 10 from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to define the model. Yeah, this is where the model is actually being defined. We're going to use a sequential API of the TensorFlow Keras API. So I'm going to use the conv, then the max2, then the conv, and the max2, then flattening it, then the dense, the dropout for regularization, and another dense with the number of classes that is 10, activation function, softmax. These are things that I think you should be knowledge about as in the data science or in the first track of this course. I'm going to fit the model. I've already done that. I've already fit the model, and I'm going to evaluate it, and I printed the accuracy because it's going to take a lot of time to train the model. So I just said that let me train it beforehand before we start training the model before we start the video. Also, we're going to save it. This is how I'm going to save the model here. Model.save it's in a TensorFlow format because TensorFlow 7 requires your model to be TF in a TF save model format before you can deploy it. Right? So that's the code that I've used today for training the model. So if you want to train the model in your end, you need to have TensorFlow installed. Then you just call Python model.py, right? That's it, and you can train the model. right? So, and it trains it and it also saves it in save model format for the TensorFlow 7 because TensorFlow 7 requires your model to be in safe model format before it can actually use it for deploying, right? So let's go on to the Docker part. All right, so it also I also require you to have Docker installed in. Yeah, these are the requirements. You need to have kind. Kind is the short form for Kubernetes in Docker. And as such, you need to have Docker in your local PC too. You need to have Docker, you need to have Kubernetes. Kind helps you deploy, like build Kubernetes clusters in your local machine. It's just like a simulation of the Kubernetes cluster, but this one is in your own local machine. And also you need to have kubectl because kubectl is the command line for the Kubernetes cluster, right? So I hope from here I can go on to the deployment phase, right? So today's going to be a short one, and hopefully you can understand what I'm doing. So first, I'm going to try and deploy to build the Docker image. Okay, so let me explain. You know, in Docker, you need a Docker file. A Docker file is a way for you to build a Docker image that is used to create a Docker container. That's just a summary of what Docker is. And hopefully you have done Docker in your previous track. So hopefully you can understand what I'm saying. So to use TensorFlow 7 has a Docker let's call it an image posted on Docker Hub. So what we just need to do is import, just do from TensorFlow 7/7 from TensorFlow/7. So Docker, we're going to download TensorFlow/7 from Docker Hub, right? And now we are now going to, what this Docker file is going to copy the trained Docker file. No, after training this model.py, it saved the model. It saved the model. Let me show you. Sorry. It saved the model in a part called image classifier. Let me show you model.py. So this model.py. Am I audible? Am I audible, please?
Yes, you are.
Okay, thank you. So here, this model.save saves it in this file part called image classifier. That's what I was saying. So in image classifier, like I did here, this ls, you see that there's a folder called image classifier where the particular model is stored. Right? So from there we can just now use the Docker file to create TensorFlow 7 Docker container that holds the TF7 image in it. So let's go from there. So this is going to build the image for us from the Docker file. And I think I've already done that. Okay, wait, I was explaining something. I think I've done that locally in my own PC, so it's going to be faster. But for you, it's going to go into Docker Hub, download the image, then load the image classifier service for you before it does anything. So this copy command copies that image classifier that I showed you before into this models folder in the Docker image. So this is where the whole model is loaded into the Docker image. And also this environment name is also important because in TF7 you can deploy as many models as you want, and you want to name the actual model that you want to use to deploy, right? And so that what this environmental variable model name does for you, right? So let's go into the building of the image. If I run the code, you see that it has already done everything, just using the kit because it has already downloaded the TensorFlow 7 Docker image. It has already copied it for me, and it has already named the environmental model image classifier. And it has successfully built the Docker image here into TF7 cluster version 101. Remember, in Docker, you need to version your images so that you can know, because you can make changes and you can also push those changes to your own personal Docker hub. So it's better for you to it's better for you to version your Docker images. Right? So let's go on. So we have built the image now. So let me explain something. TensorFlow 7 serves the endpoint in two ways. They are the REST APIs. REST API is a popular one where you use pull and put commands. Yeah, so REST APIs are the popular ones that you know everywhere, that backend engineers use and whatnot. Now also TensorFlow 7 has the second one called gRPC. gRPC is developed by Google, and it uses a kind of format called protocol buffer. And in this one, it's slower. It's slower than REST API because it allows for low latency and also like smaller payloads than REST API. And it also handles large tasks because TensorFlow models are very, very large. Like if you can go in from size to megabytes to gigabytes, go to I think to almost terabytes, and so that's when gRPC comes into place. But for our simple use case here, we can just use the REST API version, which is hosted in port 8501. So let me run this, or let me explain now. So this command here, it runs our Docker image, TF7 classifier version 1. It runs it interactively. So this 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 flag IT means that you're running interactively in your command line. So it's not going to escape from your command line front. It's going to be running in that command line front. So you have to create and open a different command line to make your prediction. Now this /p flag means that you want to host your internal port 8501 to the port 8501 of the Docker container. That was this means. So this 8501 is your local PC port, and this 8501 is the Docker image port that you are using. And this 8501 is the REST API port. Is the REST API port of your Docker image. So let's copy that and run it. Okay, so for now the Docker image is running, and it's running on port 8501 now. I know that it's in interactive mode, so it can't connect. You can't do anything on this terminal now. So what we have to do now is open a different terminal and SSH to it, right? So that's what we're going to do now. Sorry, I need to get the IP address I need here. Sorry. So I have to go to the port to my Docker image to TensorFlow and to AWS to get the IP address I have here. So that's why I'm taking time. Okay. So I just want to get the port now, the IP address of my virtual machine that I'm using, so I can SSH to it. All right, so I've SSH to the virtual machine I'm using, and now I can run the other command, the Python predict.py. So now, if I do ls, you see a predict.py file here. This predict.py file is where the prediction script is that is going to run the prediction for. So let me explain the predict.py. So in the predict.py now, what we're doing that since we've already trained it as it, what we can do is to just make the test. So that's why I put here __ because we don't need that part. So what's important is the X test and the Y test using the load data command from TensorFlow Keras, right? And so we are going to reshape it. We're going to reshape it to /1. We're going to get the previous shape and put it in just one channel. One channel is black and white, and the three channel that is the red, green, and blue RGB color. So We're not going to normalize the text set divided by the highest pixel we can have to. But that's normalization. You can also see it in machine learning, you also do it in deep learning. And also now, the most important thing now is URL. Yeah. So let me explain how this URL is gotten. Right. So this URL is gotten in this way. The HTTP slash forward slash forward slash then host. That means the local host. That means that's your port 127.0.0.1. Then your port, that's 8501, because you port forwarded your local PC port to the Docker container port. Yeah, that's what this port is, that 8501 for the REST API. The version 1, that means the version that you are using. Models, because remember that we mounted the where was that, in the code, in the Docker file. In the Docker file, we loaded our image classifier model into this slash model slash image classifier slash one. So that's why we have to use that model folder. That's where our model is. And now in the last part is the predict verb. The predict verb here as predicted. That's where there are different. Okay, let me take you guys to TensorFlow setting documentation. So they have different, like, they call them verbs, but they mean like what kind of request are you sending to them. There's the predict, there's the regress, and I think there's another one, the classify. No, we're not doing a classification or regression. We're just doing the prediction to get the prediction of the model, right? So this is the documentation for that, and this is how to send the request in this format. This everything is in your documentation. You can always check. And so now, what the next thing I want to show you is that there is always the format for you to send this request to the API, right? So the request body for predict API must be in JSON format because we're using a REST API here, right? So that's what I want to go to next to make predictions function. So I'm going to import JSON. JSON is the way of converting your dictionary to JSON, because the API does not understand dictionary, it really understands JSON, and has to be in specific formats. You need to input the signature name and the default mode is saving default. This is not important, this is optional. Now the important thing is the instances. These instances is the actual data that you're sending in to make predictions on, right? So you see here, instances does to list. Yeah, it's where we make this is where your images, your these things that we converted to we normalize it. It's done in numeric format now. This is what we're going to send here and convert to list, because it's going to throw an error if it's not in the list format, because it doesn't understand things like number arrays or TensorFlow arrays. So you have to convert it to a list since it understands the list, and it requires a list from here, nested list or list of objects. Yeah. So that's how to send your request. Then you use the post command. Since we're using Python here, you use the request package, the import request package here to send in your request, and use the post command. Also, in the documentation, they said that to make a request, you need to send a post. You have to make a post request to the URL itself, and that's how it's going to make the prediction for you, right? So you send a post request to the URL, the data is the URL. Remember, I explained the URL to us. The URL, the data itself, that's where the instances.list is. Then the headers. This is just like it supports it's supporting information, like to tell you that the content type you're working with is JSON format, right? So it makes the post request to this URL here, and the response it gets, it converts also to dictionary. So this JSON loop converts from JSON format to dictionary format. Then we take out the prediction that we need, actually that's prediction, and we return it. So that's what the function does. And also we can also see from the documentation itself that the response format is in this format. So you're sending a JSON with predictions, and then your prediction here, depending on the number you send, going to either give you a value, a nested list, or a list of objects. A list of dictionaries or something like a list of tuples, depending on the kind of model that you posted on TensorFlow 7. So, you get your prediction, and this is me now calling this function with the first four examples from tests. So the first four examples from this test, we're going to use it to make predictions. I'm going to print out the true values and the predicted values to tell you whether to show whether our model is accurate enough or not. Right. So now we're going to run the Python predicts.py. So let me convert because I created a separate environment, secondary environment for this task itself. And I'm taking it on the right directory. So I have the predict.py now. And I call Python predicts.py, right? And so you see what's going to happen now. You see that it's loading the data from TensorFlow. We don't have the GPU yet, so that's why it's showing this error of CUDA and GPU. So, and trying to make the predictions. Now, you can see that it actually was accurate enough. The true value was 7 from the data itself, and the predicted value was 7. So this is what the model said to us. Let me show you where it happened, where all this happened. It happened right here. You can see here we're printing the true value, and got it from, we're working with the first four examples. So it's going to print out the actual value from white test. It's not going to give us the value with the highest, TensorFlow, when you make a prediction with the model, it's going to give you probabilities depending on what it feels is the best answer to this. So what came out from here, the prediction was a list of numbers, that probabilities from 0 to 1, and the one with the highest probability is the one that is the prediction, the right prediction. So that's np.argmax returns the index with the highest probability. So, and that index is the one is the predicted value for that particular example. So what it did was it used the white test and gave us the predicted value. That's 7. And you see that our model is it's quite accurate enough. So let's move on to deploying this model to Kubernetes. So like I said, this is just like a local, a simpler version, a simple version of Kubernetes actually, because this is on a local machine. Normally Kubernetes, you need to either build your Kubernetes cluster yourself or use one already in the cloud. So since this is just a tutorial, I don't really need to go that far. So, but it can also be replicated on any Kubernetes cluster, either on Azure or AWS. So what I'm using today to for my local deployment is kind, and you also see people use Minikube. Yeah, I think in the track for this section or last session was, I think they introduced Minikube for the, but kind is also easy, and kind zone is kind of different because you can just use Docker images and it works fine. That's why they call it Kubernetes in Docker. And so at first, since we have gotten the TensorFlow 7 model and it's running, we can just end this here, and it's fine. So now we want to deploy this model on Kubernetes. First thing we need to do, because we're using kind, we need to load this model into kind. Another thing we could do instead of this is load our TensorFlow classifier into Docker Hub. Then in our YAML file, we download from Docker Hub instead of our local PC. But since we already have the image in our local PC, we can actually use our local image instead of uploading it to Docker Hub, right? So let's continue. So this is loading the Docker image, TensorFlow 7 classifier. Remember here, I've cleared that. Remember here, we built this Docker image, CF7 classifier version 01. Yeah. And so we're just loading that image into kind. But kind is like a Kubernetes cluster on your local PC, and we're just loading that Docker image into that Kubernetes cluster, right? Instead of going through Docker Hub. So I've already done that personally, and that's why it's telling me that the TF7.1 is already, its ID is already found in the node. So what's next is now creating a Kubernetes pod and service, right? So let's go into that. Sorry, what was my screen not showing before?
Yeah, we can see. We can
Sorry,
see.
hello. Was it ever off? Was it ever blank?
No, it wasn't.
Okay, thank you. So let me show you how the YAML file. You know, in Kubernetes, you need to you work with YAML files, and the YAML files are used to create the pods and your services, right? So let's go into that. So in this particular Docker, this particular Kubernetes cluster, we're going to create a pod, the deployment that is named TF7 classifier. Then you know they select pods depending on the deployment, and we are going to select pods of TF7 classifier to be together. Now the individual app that is running in the individual pods, sorry, are going to be named TF7 classifier. I hope you understand what I just said. So what I said again is that a pod will be named TF7 classifier, and now a group of pods, that's the deployment, is going to be, they're going to be like running the same service or the same container, going to be called TF7 classifier. And now the name of the deployment is TF7 classifier, right? And so in this pod, we're going to run this Docker image TF7 classifier that we uploaded, we loaded into the client cluster. And also we set limits memory of 128 megabytes and 500. This 500 M means like half of your virtual CPU or CPU. That's what this 500 M means. If it was one, I would say 1 M is going to use one virtual CPU. It's kind of tricky in this, but that's what I mean. 500 means 0.5, which is half of your virtual CPU. And memory is just your RAM, the amount of RAM you need to use from your cluster, or from your local PC, or whatever you're using, a virtual machine, or whatever you're using there. And now the port for this that's going to be open for this port is port 8501. Okay, so let me try and run the start the pod, the Kubernetes, the deployment. Okay, so the deployment is up, and I think to get so it's running now. It's running. You can also see CTL get deployment. Yeah, you see that the deployment is up and running now, and so we can create the service that is used to get to make requests to the pod itself in the deployment. So let's start off the service, and you see that the service is created, and we're now going to get the response or the state of the service. And we see that TF7 service is up. Now, I need to make a note that this external IP, if we were working with a cloud service like Azure, AKS, or AWS, Kubernetes clusters, we need to get an external IP, and we can access it from the internet, like from our phones or from anywhere. But since we're doing this on a virtual machine, our local PC, we're not going to get an external IP. It's going to be just a normal cluster IP. And yeah, and so since if we want to access the model itself, what we have to do now is we have to port forward our local port to the ports of this service that is connected to that deployment, right? I think I need to go back and explain that. The service.yaml. So we see that we created this, the name of the service TF7, and it's going to work with a pod, and that pod is that's the TF7 classifier pod we just created now. Yeah. And so to access that port, the port of that service, because we don't access the port directly, we access the port through a service. And so the port for that service is port 80, and the port for the port is 8501. So the service is interacting with the port at port 8501 because that's where the REST API is open on the port in that container. And the open port for this service is port 80. Yeah, so to access that port, you have to go through this service. And so to do that, we have to port forward our local port to that particular port of the service. Yeah. So to do that, we're going to use this kubectl port forward command to do that. TF7 port that save SEC. Let me confirm from here. Okay, so I think I put in the wrong name for this portfolio. TF7 SDC. Yeah, so right now the port that's open is port 8080 connected to port 8501 of that port. Now to make a request, you have to make a little change to our Python script, our Python predict script, because it was pointing to port 8501, and if you try to do that, it's not going to it's nano. Sorry, I'm trying to make a change with my command prompt because I couldn't access the virtual machine from my VS Code. Yeah, so I have to make a change to this port here. Yeah. So because this port 8080 that is open right now, I have to make a change so that to access that particular port that is open for TF7. So we save. When we save, now we can run predict.py. Hopefully we get our prediction. Yeah, so from here we can see that we got our prediction from the Kubernetes cluster. And like I said before, because we're not working with a cloud platform, or we've not built a Kubernetes cluster from the ground up. That's very, very difficult. We haven't got an external IP, and that's why we couldn't access the service straight away from online. Yeah, so we have to port forward our local PC port to the port of the service so that we can access the model that we TF7 service from our local PC. I hope that was makes sense. So I think this will be the end for the session for today. If there are any questions, you can ask me now. Any questions? Can anybody hear me?
Okay, thank you very much, Joaquin, for that session. Please, there's a little bit of background noise from your side.
Sorry.
Okay, it has stopped.
Okay.
Okay, thank you very much for that session. You guys know the drill. If there's any question, drop it in the chat. Those on YouTube also. I hope you got an understanding of what he taught. And also, if you don't grasp the whole process, probably if it was too fast or something, you can always go back to the video. It's available on YouTube, and you would get a hang of it. So we're going to have like a few minutes for Q&A. If there are none, you can call it a day. Any questions? Okay, I guess they got a good understanding of the whole concept. Well, as usual, you can always go back to the video and grasp or understand everything you just talked about. So, in the absence of no further questions, thank you very much, Ohakim. Thank you guys for joining those on YouTube and also on Zoom. Have a lovely day ahead. See you next time.